chemicals well defined, described. If peptone existing, it is a complex medium. Because these have unknown chemicals. That's way to study. Okay. Okay. Let's look at other questions. Question 38. Then we go back to talk about that difficult one. Question 38. All fastidious microorganisms require which of the following to grow? Oxygen. Every bacteria needs oxygen. Some of them needs oxygen. So not really. Iron, the D, you can cross it. Doesn't matter. Temperature near normal for the human body, that's most of the bacteria needed, not fastidious. And I said that. This is actually an easy question. Remember the bracket there, such as chocolate agar? Chocolate agar is for fastidious bacteria grow because there is extra nutrients. So therefore, we come out with chocolate agar. This is for fastidious bacteria. Okay? That's extra nutrients. Okay. Now let's see some of the one. Okay. Blood agar is both a differentiated and enriched media. Is that correct? True or false? Yeah, it's true. How we differentiate? And I said this slide is very important. So you should go back to see one of the slides, which is on the lecture 4. There is one slide very important, talking about right here. It is a differentiated media. It is all because alpha, beta hemolytic, and we also mentioned gamma hemolytic. We will mention this again in the examination too, very important. But at the same time, blood agar is an enriched media because of the hemoglobin there. So, look at the top. Enriched and differentiation medium, blood agar differentiated for hemolysis. So, blood agar has two functions, enrichment and differentiation. The answer is it. Okay? And you could even mark this correlation to question 40 for our example. Okay, so the answer is true. Let's look at question 39. You would like to culture bacteria that is growing in the lung of a human patient with ammonia. What media would be used in culturing this organism? Transport media, mannitol salt agar, McConkey agar, none of them. Look at the D. Complex media was supplemented with whole blood. This question is difficult. That's why you see the bracket, extra point to 1 point. Why? Because this is test to you. You need to understand these slides. It's a blood agar. And what are those passions? Streptococcus ammoniae, alpha hemolytic, Streptococcus pyogenes, beta hemolytic. Those could be related to lung disease. So, answer is complex media supplemented with whole blood. And this question, why it is difficult? Because it will test you that slides, do you understand? Which means the application results from that slides. And I think it's difficult, so I gave you extra point if you know. Okay? That's the story behind it. Now let's see other questions. Then we go for other things. Okay, we don't have, not here. Okay, now let's look at difficult questions. Question 39. Mannitol salt agar. We will do this in the lab later on. Okay, and I said about the bacterial media. The difficult thing is not to understand each individual function. The difficult thing is that there are multiple ingredients in there, will confusing you, and those media could be a selected media, could be a differentiated media, could be a combination of one or two. So, and based on the story, the description, you have to do the puzzle. So let's talk about the mannitol salt agar. And I don't need to read, I know what it talks about. There is a two ingredients here, which is mannitol is a sugar and the salt is an ingredient. You know that. So first of all, bacteria does not like salt. Some of them like, some of them does not like. Do you remember halophiles? Remember? 0.2 mole salt, sodium chloride. Some bacteria could survive, some bacteria could not survive. And I said some bacteria could survive. We will talk about with Staphylococcus aureus. That is the reason why on the skin surfaces we have Staphylococcus aureus. That's the reason why chicken nugget or chicken salads is a risk, because people doing these things. Then Staphylococcus aureus will be there. Therefore, this ingredient is a selective reagent. Is that right? They could differentiate halophiles versus non-halophiles. How about mannitol? Mannitol is a sugar. Now you always remember, if there is a sugar in the agar, basically it's for biochemistry reaction, and we want to see the color change. Therefore, it comes out with two different results. Is mannitol fermentation positive and mannitol fermentation negative. If mannitol fermentation positive, it is yellow color. Otherwise, it is colorless. So, this bacteria media is a selective media or differentiated media or both. It depends, the story. Then you go back to read what it talks about. Okay, let's go back to look at the question 37. Mannitol salt agar only allows the growth of halophiles, salt-loving microbes. Non-halophiles will not grow. Among the halophiles, mannitol fermenters will produce acid that turns pH indicator yellow. Mannitol non-fermenter leaves the medium red, which is colorless actually. On to mannitol salt agar, you introduce a halophilic mannitol fermenter and a halophilic mannitol non-fermenter. Then what's the media acted for? Look at what the bacteria you're adding. Is halophilic mannitol fermenter and the halophilic mannitol non-fermenter. What are the bacteria you put here? Halophilic mannitol fermenter and the halophilic mannitol non-fermenter. If you grow these two bacteria on the mannitol salt agar, what's the function of this mannitol salt agar? They both will grow because they're both halophilic. Therefore, they don't have selective function because it's all going to grow. You're not going to see. If one of them not grow, you will see. They not grow. It's picky from one of the two. That's selective media. You have a mannitol fermenter, mannitol non-fermenter. What's the results will comes out? The color will be changed. One is yellow, another one is red, or colorless. So, this, the function is a differentiated medium. Okay, now, if we want to make it a little bit complicated, if the media is now halophilic fermenter and halophilic mannitol non-fermenter, then what is that media for? It's a selective medium. And also it's a differentiating medium. So you really have to read it. And we can also change it. If it's a halophilic, non-halophilic. However, this is all magnetofermenter. So what you're going to see? It's a selective medium. Because halophilic and non-halophilic is dependent on the source. Okay, so either one of them or both, really you have to read the question. What type of the bacteria it is. Okay, not just to go ahead and pick the C, because our slide says that. That's a kind of difficult question, usually. Okay, one or two, like that. Okay, so that's you have to read. But many of those are worth to practice in the lab, so you know about what it is. Okay. We talk about these things already. Then let's look at the other questions. Let's look at some other questions. Okay. Most bacterial cells divided by what? Mitosis, meiosis, you don't even heard about it. The binary fission. Is that right? The answer is C, very correct. Let's talk about that question later. Okay. 42 is a little bit difficult. The blah 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 is the length of the time it takes for a population of microbes to double in number. What's the answer for that? Is that called generation time or doubling time? That's generation time. Okay? Now, let's move on to one of the topics we want to talk. Then we're going to talk about the mass puzzle. So another thing we talk about in the class is a bacterial growth curve. Do you still remember what the bacterial growth curve looks like? Can you draw it? You should remember what it looks like. Okay, bacterial growth curve. Okay. Lag phase, everything preparation. Log phase, it's grow dramatically, doubling. Stationary phase, because wastage comes out, so live and dead cells start to balance, and finally will start to die, because toxication material generates death phase. Is this correct? Lots of people will write like that. Then you have problem. Well, kick off 2 points. Why? What is x-axis for? Time, minute, maybe hour. Is that right? You have to label x-axis what it is. What is the y-axis? Number, population. At least, okay, maybe cell per ml. That's a common sense. What's the y-axis? What's the x-axis? Now, let's look at this puzzle. We already talked about doubling time, question 43. We already talked about it. Now let's do a mass puzzle, okay? Giving a log phase bacterial culture with 1 multiple by 10 to the 6 cells per ml, and a generation time of 30 minutes, how long does it take the culture to reach a density of 6.4 times 10 to the 7 cells per ml? Okay, we know that. Original, it is 10 to the 6. We need to do is 6.4 multiplied by 10 to the 7. And the generation time is 30 minutes. How to do it? Okay, first thing. This is 7, is that right? This is 6. We need to become the same. Okay. 6.4 multiplied by 10 to the 7. It is 64 multiplied by 10 to the 6. Is that correct? Okay. Therefore, what's the difference? This is the 1, okay? 1 becomes 64. Then how to do it? What it means the generation time? It's a doubling time. Doubling time, which means 1 becomes 2, 2 becomes 4, 4 becomes 8, 8 becomes 16. So what are these for? 2 equals 2 times 1. 4 equals 2 times 2. 8, 2 times 3. 16, 2 times 4. 32, 2 times 5. 64, 2 times 6. 128, 2 times 7. What's the answer we need to find? Is it right here? Is that correct? So, this equals. That means how many generations? 6. Yes, 6. 6 generations. One generation is how many times? 30 minutes. And you also need to know 30 minutes equals 0.5 hours. Okay? So, last math. 0.5 multiplied by 6 equals what? 3 hours. I'm a good math teacher. If everybody teach like this, you're going to be good A in the math classroom. Is that right? Okay, that's what the question for. It's a fun question. It tells you what's the generation time. It's a doubling time. That means 2 times 1, 2, 3, 4. Then you can write it. If you don't know, just write these. This is the same thing. Okay. 16 divided by 2. If you don't know. Is that going to be 1? No. Is that going to be 2? No. Is that going to be 3? No. There's a way to do it. You can draw 16 circles. Is that right? That's the easiest way to do it. If you don't know, just draw like that. Divided by 2, how many? Then count. There are all kinds of ways you can do it. You know, you may not remember, but for the math puzzle, lots of the things you could draw, and then you remember. If you don't know, just draw these. And that one, the index there means a generation. Because that's what the doubling time means. It's a 1 generation become 1 become 2, 2 become 4, 4 become 8, 8 become 16. And the generation time is needed 30 minutes, 0.5 hour, so it's needed 3 hours. Okay, it's a fun question, to be honest. Okay, if we change the number, can you do it? You can do it, is that right? And if we change to 3.2, you can do it. Maybe difficult, 12.8. A little bit complicated, but no more than that, because it's not realistic. It's only about reach to like 8 level. 8 level. You won't be go all the way to the top. Okay, so it's a fun question for you. Okay, now other questions. There's some question right here from 46, 45, 46, 47. That you have to remember. There's nothing like tricky here. Okay. Organisms that grow well at 0 degrees Celsius have an optimal growth temperature of 15 degrees Celsius, or lower or cold. That's question 45. It's called what? The cycrophiles. Is that correct? If you forgot, these questions, if you forgot what we do, we go back to look at the slides. Cycrophiles. Okay? So that's something you go back and look at the slides. Organisms that do not require oxygen for growth, but grow better in the presence of oxygen for the what? It's not allottorant. It's not anthogenic. When you see these choices, the D, you cross it out. You never heard about it. Cross it out. Then you only left 3. Okay, is that macroallophilic? Of course not. Macroallophilic, when you see arrow there, which means they need some oxygen. But that does not require oxygen for growth, but grow better. So allophilic is gone. Allotolerant, which means you're equal with or without oxygen, grows better with oxygen, is facultative. And if you forget, there are slides for that right here. That's a complicated one. Now I have another question for you. Why Campylobacter, why Clostridium is an anaerobic bacteria? Let's do a puzzle, okay? Why Clostridium is an anaerobic bacteria? Lots of the people tell me because Clostridium is not an aerobic bacteria. Lots of people say that because Clostridium is not aerobic bacteria. If you see this answer, that's not going to give you too much points. Because you're paraphrase the question. I mean, right now we can talk about that. I used to make a joke. This is the same thing like I ask you why he's a boy. The answer is tell me he's not a girl. Okay, we don't have to discuss this topic anymore. But I used to make that joke. Which means when you answer the question, you need to tell a story behind it. You're not going to be paraphrase the older question. Okay? So, what's going to be the question? Why? Because there is no SOD nor patterns. Is that right? That is the reason why Clostridium is an anaerobic bacteria. Okay, so when you do these things, you undergraduate, you need to go a little bit deep. One depth ahead compared to at the surface, then you're gonna understand this question very well. Okay, so that's something we want to mention, or we want to emphasize. So that's this question. Most of let's see 47. Most microorganisms maintain their internal pH. Well, this is easy, near neutral. Okay. Near neutral pH 7. But this question, like a B, is not very good because near their optimal growth pH, most of them is like 7. And this is kind of like tricky for that. So that year, if you choose B, I mean, I still gave you points because I don't think its wording is very well. I mean, it's a wording a little bit, you know what I'm saying? Because every bacteria theoretically have their optimal pH. Most of them is neutral, but some of them are not. So this B kind of like a wording not very nice. It's kind of confusing you. So the year you choose B, I still give some points, but the best answer is A. Okay? Okay, let's look at something else. Organisms that ignore oxygen and grow equally well in its presence of vaccines or carbon. Allotolerant. Is that right? C. Allotolerant, because we already have a slide describing that. Now let's look at 50. Go back. When grow on a blood agar, a clear zone around the colonies of Streptococcus pyogenes indicate. Okay, I said that slide is important, but we won't mention again. Then we go back to see it. You understand it. We go back to redo it, see it. What's that? Beta hemolytic, right on the top, with Streptococcus pyogenes. Now you have to know Streptococcus. We often use just write S. Okay? This is kind of confusing. Staphylococcus also just write S. Of course, it has to be italic, so it's a little bit like confusing you. So, but you know the Streptococcus pyogenes is alpha hemolytic. Okay, so that question. Okay, at the other. Okay, let's look at something else. We left some question haven't answered yet. Then let's just finish those. Okay, major question we already talked about. The energy required for transport via ABC transporter is derived from. What is ABC transporter? What does that mean? ATP binding cassette transporter, that's called ABC transporter. So the answer is obviously it is ATP hydrolysis. Is that right? That's ATP hydrolysis. Okay. Let's look at here. Samples from a barrel river lake was numerated by both pore plate and spread plating procedure. If fewer colonies appear on the pore plates and spread plates, it is likely. And I mentioned that there is one disadvantage of pore plating compared to spread plating is because pore plating we use melted agar. And usually the melted agar is at 50-55 degrees Celsius. So there's some of the mild heat. Those mild heat could kill some of the bacteria if they are heat liable or heat sensitive. So, what is the answer? The B answer is heat sensitive microbes may be killed or were killed. That's why you will get a lower number. We will do this in the lab next week. We will do spread plating on Tuesday, pore plating on Thursday. Then you can compare, see the number. It's completely less, which is a pore plating. Okay. Question number 53. There are examples of proteins that are resistant to the antibiotic penicillin. Provide one simple explanation for how microbes could be resistant to penicillin. Well, very simple. What's the reason? Because of all plasmid. And we mentioned about the plasmids, it's a linear or circular small sequencing. It could be integrated or individually compared to the chromosome. And some of them carry very important information like antibiotic resistance. So, if something really resistant to the penicillin, then it's with all plasmids because they carry on that. Okay, this is a very simple question. Now let's look at this one. There's a little math, but it's easy. Which culture has the longest lag time? Which one? Yeah, number 4 have a longer lag time. Which culture has the fastest growth rate? It should be what? Culture 2, is that right? Could be because it's very steep. The slope is very steep. Which culture has a short